Hi friends, in this video we are going to see the JEE main previous year questions in the topic chemical kinetics, and we are going to see the questions related to rate of reaction, rate loss and rate constant. Let's get started. First, let us see the key concepts. Here we are going to discuss only the important formulas. We are not going to see the concept in detail. First, what is chemical kinetics? It is the branch of chemistry in which we will study the rate and mechanism of a chemical reaction. What is rate? Speed of a reaction. So some reactions are very fast, some reactions are very slow. So how to differentiate between them? You have to see the speed of the reaction, that is the rate of the reaction, and you have to find the time taken for the reaction to be completed. So the word kinetics is derived from a Greek word kinesis, which means movement. That is, there is a change in the reactant when it is getting converted into the product. So that change here refers to movement. So if you consider a simple reaction A gives B, how to define the rate of the reaction, that is speed of the reaction? Rate is equal to change in concentration of the reactants divided by change in time. So let us consider the reactant having a concentration A1 at the time T1, and the concentration changes to A2 at time T2. So the change in concentration of the reactants is final concentration minus initial concentration. We know that concentration of reactants decrease. So if we subtract final concentration A2, concentration is represented by square bracket. So if we subtract final concentration A2 minus initial concentration A1, then we will get negative value because concentration of reactants decrease. So what is the meaning? Concentration of A2 is less than concentration of A1. So when you subtract this, you will get a negative value as the concentration of A1 is greater. So minus delta concentration of A. But speed, that is rate, cannot be negative, no, it will be only positive. So you have to change this negative into positive. So for convention, in this formula itself, you have to include a negative sign. This negative sign is only for the reactant. For the product, this negative sign should not be given. So change in concentration of the reactants. So minus concentration of A2 minus concentration of A1 divided by T2 minus T1. That is, the denominator is change in time. So the final time minus the initial time. So we can write the rate as minus delta A divided by delta T. So this delta A value will be negative, no? Already you are having a negative sign. Then you are having negative delta concentration of A divided by delta T. So the negative into negative will become positive. So the rate of the reaction will become positive for the reactant A. Why this negative sign is not included for B? Because the concentration of products increases over time. So if I subtract B2 minus B1, I will get positive value. So no need to write the negative sign. So what is the unit of rate of the reaction? So rate is concentration divided by time. So I will write here rate is equal to concentration divided by time. Concentration is measured as moles per liter and time is measured in seconds. So the unit of rate of the reaction is mole per liter per second. So this moles per liter is nothing but molarity. So usually molarity is represented as capital M. But in this chapter, we are going to write as moles per liter itself. So the unit of rate of the reaction is moles liter inverse second inverse. In some cases, time can be measured in minutes and years also. So it depends on the reaction. So we'll go to the next concept. So if you consider a reaction, A gives 2B. For this reaction, you have to write the rate of the reaction. For 1 mole of disappearance of A. A is the reactant, so it is going to disappear. 2 moles of B appears. So if I want to write the rate of the reaction for B, so the change in concentration of B divided by change in time, and B is the product, so you have to write plus, no need to write negative sign, is equal to, so as we saw, 2 moles of B appears when 1 mole of A disappears. So how to write the rate of B with respect to A? The rate of formation of B is 2 times the rate of disappearance of A. And as A is the reactant, you have to write the negative sign. If you rearrange this equation by taking the 2 to the left hand side, then you will get 1 by 2 rate of formation of B is equal to minus rate of disappearance of A. So we can tell that rate of a reaction is equal to rate of formation of product, or you can also say rate of disappearance of the reactant divided by their coefficient in a balanced reaction. So in this balanced equation, the coefficient of B is 2. So for the rate of the formation of B, you have to divide that by 2. So the rate of the formation of the product divided by the coefficient. So this is the balanced equation in which you can find the rate of the reaction. So if you consider a equation XA plus YB gives products, for this we can write the rate law. So rate of the reaction is directly proportional to the concentration of the reactants A and B, and concentration of A is raised to a power of m, and concentration of B is raised to a power of n. So this power m and n is called as the order of the reaction. That is, if I increase the concentration of A 2 times and the rate of the reaction also increases 2 times, then the power is 1. So it means that the reaction is first order. If I increase the concentration of A by 2 and the rate of the reaction becomes 4 times, then the power is 2, second order. If I increase the concentration of A 2 times and there is no change in the rate of the reaction, then the power is 0, zero order reaction. So this power m and n may or may not be equal to the coefficients. So you are going to introduce the proportionality constant for this equation. Rate is equal to K A power m B power n. This K is called as the rate constant. So the unit of rate constant for zero order reaction, first order reaction and second order reaction is given. For first order reaction, it is second inverse. For zero order reaction, mole liter inverse second inverse, and for second order reaction, it is mole inverse liter second inverse. So you may think how to find the unit of rate constant. If you rearrange this equation for rate constant K, K is equal to, by taking these two terms to the left hand side, rate divided by A power m B power n. We know that rate of a reaction is having the formula concentration divided by time, and 1 divided by concentration of A and concentration of B is given. So if we take the concentration of A and B as same, so generally we can write concentration. So the value will be same, and here the overall order of the reaction is m plus n is equal to x. So if the order of the reaction is first order, then concentration power 1. If the order of the reaction is second order, overall order is second order, then concentration power 2. And if it is zero order, so concentration power 0. So anything power 0 is 1. So then these two terms will be there, and already I told concentration is written as mole liter inverse second inverse. So mole liter inverse is the unit for concentration, and second inverse is the unit for time. So this is the unit for the rate constant for zero order reaction. And if you want to find for the first order reaction, here instead of 0 you have to write 1. So the concentration term gets cancelled. So the unit of time is second, and it goes to the numerator, so it is second inverse. So in similar way you can find the unit for the second order reaction. So we will go to the next point. The next point is the total number of reactant species involved in an elementary step is called as molecularity. So you have to know this. Then the next important formula which is used in solving the problems is the integrated rate law for the first order reaction. The rate constant is given by the formula 1 by T ln A naught. So the concentration of A naught is the initial concentration. Then the concentration of A is concentration at a given time. So it is actually a derivation. From the derivation we have got the rate constant for the first order reaction. Then you have to convert this natural logarithm into log to the base power 10. So for that you have to multiply by 2.303. So rate constant of the first order reaction is equal to 2.303 divided by T log to the base 10 concentration of A naught divided by concentration of A. So if you take this first equation and rearrange by taking the T to the left hand side, then you will get ln A naught minus ln A is equal to KT. So you have to rearrange this equation for ln A. Ln A is equal to ln A naught minus KT. So this equation, as you can see, is in the form of straight line equation y is equal to mx plus c. So when you plot graph for ln A and time, you will get a straight line with negative slope. So the negative slope will give you the rate constant value. So the graph for a first order reaction is between ln A and time t. So we will go to the next step. The next important concept is the integrated rate law for the zero order reaction. So here you have to remember the formula. Rate constant of the zero order reaction is equal to concentration of A naught, that is initial concentration, minus the concentration at a given time divided by T. So if you rearrange this equation by taking the T to the left hand side and write the equation for concentration of A, then you will get concentration of A is equal to concentration of A naught minus KT. So this equation is also similar to y equal to mx plus c. So here if you plot a graph between concentration of A and the time, so you will get a straight line with negative slope, that is minus k. So it gives the rate constant. So what is the difference between the graph of a first order reaction and the zero order reaction? In first order reaction, the graph is plotted between ln A and the time. In zero order reaction, the graph is plotted between concentration directly, concentration of A and the time. So this is the difference in graph. So the next point is half-life period of a reaction. Half-life is the time taken by the reactant to reach 1/2 of its initial concentration. For example, if you have a reactant with the concentration A naught at time T naught, then for the concentration to reach half of its initial value, what is the time taken? So for example, it takes 30 minutes. This 30 minutes is called as the half-life of the reactant. So you have to represent it by T1 by 2, T half. So for a first order reaction, half-life is given by the formula T1 by 2 is equal to 0.6932 divided by K. So here the half-life of the reactant does not depend on initial concentration of the reactant. As you can see, it depends on the rate constant, but it does not depend on the initial concentration because concentration term is missing. So it does not depend on the initial concentration of the reactant. Half-life period of a zero order reaction. T half is equal to concentration of A naught divided by 2K. So zero order reaction half-life depends on initial concentration. So you have to remember this formula. So we will go to the next concept. The last concept is Arrhenius equation. So Arrhenius suggests that rates of the reaction depends or it varies with the temperature, and he gave the formula rate constant is equal to capital A, which is the frequency factor, e power minus EA. EA is the activation energy divided by RT. R is the gas constant. R is gas constant, which is given here, and T is the absolute temperature in Kelvin. So what is this frequency factor? Frequency factor tells about the number of effective collisions that happens between the reactants to produce the product. So this frequency factor is a constant value. And what is this activation energy? Activation energy is the minimum energy a reactant should have to complete the reaction. So if you solve this equation for two different temperatures and two different rate constant, you will get this equation. Log of K2 divided by K1 is equal to activation energy EA divided by 2.303 R T2 minus T1 divided by T1 into T2. You have to remember these formulas. So again, I'm telling, I am not explaining any concept in detail. Just we are seeing the key concepts so that it will be easy for us to solve the problems. So let us go to the first question. The first question is, rate law for a reaction between A and B is given. R is equal to K A power N B power M. If concentration of A is doubled, so the new concentration of A dash is equal to 2A, and concentration of B is halved. So the new concentration of B dash is equal to half 1 by 2 of B from their initial value. The ratio of new rate of reaction to the initial rate of reaction. So you have to find R2 divided by R1. So this rate R is taken as R1. R1 is equal to K A power N B power M. Let us find the new rate. R2 is equal to K A dash power N B dash power M. R2 is equal to K, value of A dash is 2A. 2A power N, value of B dash is 1 by 2 B power M. So let us write K, and if you take this A power N, concentration of A power N and concentration of B power M. So the leftover is into 2 power N divided by 2 power M. So this one we can write as R2 is equal to 2 power N. When 2 power M goes to the numerator, it will become minus M. 2 power N minus M because the base is same. And we are having K A power N B power M. So you have to find the ratio of R2 divided by R1. So just to divide R2 by R1. So here you will get K A power N B power M. So these terms will get cancelled, and the answer is R2 divided by R1 is equal to 2 power N minus M. So the correct option is option A. The next question is, reaction A gives 2B plus C. So a reaction is given. A gives 2B plus C. It is a first order reaction. It was started with the pure A. So at time t equal to 0, they are telling that it started with only A. So here pressure of the system is given. So at time t equal to 0, only the reactant will be present. So the pressure of the system will be the pressure exerted by the reactant A. So let us keep that as P naught. Because pure A means the products are not at all formed. So there is no pressure exerted by the products. Now in this table, the pressure of the system at time t equal to 10 minutes and infinite minute is given. So at time 10 minutes, We don't know the pressure exerted by A. So let us keep that as P naught minus X, because here the coefficient is 1. So it reduces 1x times from the initial pressure. Then we are having the product. Here the coefficient is 2. So it increases 2x times when you compare to the initial pressure. Then C, it increases x times. As the reactant decreases, you have to mention the negative sign, P naught minus x. Then at time t equal to infinite, at infinite time, the reaction is said to be completed fully. This is a hypothetical condition. So at infinite time, the reactant A is fully converted into the products. So here you have to mention 0, and the partial pressure exerted by the 2B product is 2 P naught, 2 times of the initial pressure, and the C is P naught. So here the total pressure is given. The total pressure of the system. So at time t equal to 10, the total pressure is 160, and infinite time 2 P naught plus P naught, the total pressure is 240. From this we can find P naught. 3 P naught equal to 240. P naught equal to 240 divided by 3. So the value of P naught is 80. So the pressure exerted by A, P naught, is 80 mm of Hg. So we found out the value of P naught. Now let us go to the time 10 minutes. So here the total pressure is given as 160. So let us write P total is equal to sum of all the partial pressures, P naught minus x plus 2x plus x. So P total, which is 160, is equal to P naught plus 2x. So we can find the value of x. Rearrange this equation. 2x is equal to 160 minus P naught. We already found the value of P naught as 80. So 2x is equal to 160 minus 80. X is equal to, here we will get 80 divided by 2. So the value of x is 40 mm Hg. So when you substitute this value of x in the partial pressure of A at time 10, then what will you get? Partial pressure of A at time t equal to 10 minute is equal to, is taken as the formula P naught minus x. So P naught value is 80 and x value we have found as 40. So you will get the value as 40. Now let us see the options first. Which of the following option is incorrect? Initial pressure of A is 80 mm Hg. So initial pressure is P naught, which is 80. So the first option is correct. The reaction never goes to completion. The second option is also correct, because for all the first order reaction, the concentration or the pressure decreases exponentially. So practically, the reaction never goes to completion, but theoretically, when time t approaches infinite, so at t equal to infinite, then the reaction goes to completion. So practically the reaction never goes to completion. Then option C, the rate constant of the reaction is 1.693 minute inverse. So you have to find the rate constant. We will see this. Then first we will check option D. Partial pressure of A after 10 minutes is 40 mm of Hg. So partial pressure of A after 10 minutes is P naught minus x, which we found as 40. So option D is also correct. So A, B, D is correct. So definitely option C is only wrong. We will check that. How to find the rate constant of the reaction? So already they have mentioned it is a first order reaction, no? So for first order reaction, rate constant is given by the formula K is equal to 2.303 divided by T time, then log of A naught. Here we are referring to pressure, partial pressure. So P naught divided by pressure at any time. So PA. So let us consider the time 10 minutes. So you have to substitute that here. K is equal to 2.303 divided by T is equal to 10 log of P naught value we have found as 80. 80 divided by, then PA at time t equal to 10, value is 40. So when you solve this, you will get, here you will get log 2. So log 2 value is 0.3012. So K is equal to, so I will write here, K is equal to 2.303 divided by 10 into log of 2. Here you will get 2. Then what is log of 2 value? 0.3010. When you solve this, you will get the K value as 0.0693 minute inverse. But in question, it is given as 1.693, which is wrong. The actual rate constant for this reaction is 0.0693 minute inverse. So option C is the correct answer. The next question is, for the reaction A gives B, the following graph was obtained. The time required for the concentration of A to reduce to 2.5 gram per liter if the initial concentration of A was 50 gram per liter. So the initial concentration of A is given as 50 gram per liter, and the concentration of A at some time is 2.5 gram per liter. So what is the time required to reduce the concentration from 50 to 2.5? So we can simply find this by using the rate law. So the integrated rate law you have to use, but the problem is you have to know whether it is zero order reaction or first order reaction. So for that, you see the graph. So the graph is not a straight line. So we know that for first order reaction and zero order reaction, a straight line with negative slope is the graph we obtain. But here a straight line is not given. So you just see the values. So for the concentration 50, the time is 0. For concentration 50, the time is 0. And for the concentration to reduce to half, that is for the concentration to become 25, what will be the time? Here the concentration to reduce to 25, the time is not mentioned. So the time is not given correctly. So let us skip this and go to the next value, 40. So the concentration 40 is obtained at time 5. So after 5 seconds of the reaction, the concentration is 40. Then for 40 to reduce into half, that is 20. What is the time? So if you note down the time, the time is 15. So if you see the difference in time, the difference is 10. So for the concentration to become half of the initial concentration, the time taken is 10 seconds. Now let us see another two values. So now let us take the concentration 20 itself. So at 15 seconds, you are getting the concentration value as 20. Then what is the half of 20? Half of 20 is 10. So for the concentration to become 10, the time required is 25 seconds. So let us compare this. So for the concentration to be 20, the time taken is 15 seconds. And for the concentration to become its half, the time is 25 seconds. Now again, the difference is 25 minus 15, so which is 10 seconds. So whatever the concentration, the half-life, that is the time required for the concentration to become half of its initial concentration, is same. So the half-life for this is also 10 seconds, and here also the half-life is 10 seconds. We know that for a first order reaction, half-life is given by the formula T half is equal to 0.693 divided by rate constant, and it does not depend on the concentration. So here also the half-life is same, and whatever the concentration, you are getting the same half-life. So it tells that it is a first order reaction. So using the first order integrated rate law, you can find the time required. So what is the first order integrated rate law? Rate constant is equal to 2.303 divided by time into log of initial concentration divided by concentration at some time. So we need to find the time taken. So just let us take the time to the left hand side and bring the rate constant to the right hand side. So T is equal to 2.303 by K. We know the A naught value as 50 and we know the A value as 2.5. We need to find the rate constant. So for that, let us use the half-life formula. T half is equal to 0.693 divided by K. So you have to find the rate constant K. So here itself we saw that the T half value came as T half is equal to 10 seconds. So let us use that here. So rearrange for rate constant 0.693 divided by T half. K is equal to 0.693 divided by 10. So rate constant is equal to 0.0693, and as it is a first order reaction, the unit is second inverse. So let us substitute the values. T is equal to 2.303 divided by 0.0693 log of 50 divided by 2.5. So T is equal to 2.303 divided by 0.0693 log of 50 by 2.5 is 500 by 25. So the answer is 500 by 25 is 20. So when you solve this, you will get 2.303 divided by 0.0693. Log 2 value is, so we know the value of log 2, right? 0.3010. Here you are having log 20. So 2 digits are there. So you have to write 1.3010. So here the answer is log 20 value is 1.3010. And if you solve this, you will get the answer as totally you will get 43.23. So the nearest integer is 43.2 seconds. So the answer is 43 seconds or 43.2 seconds, 43 seconds. The next question is A gives B plus C is a first order reaction. For this reaction at time t, the total pressure P system is total pressure is given as PT, and at time infinite the total pressure is P infinite. So this information is given. The reaction was started with the reactant A only. Which of the following expression is correct for rate constant K? So the given reaction is a first order reaction, and we know the rate constant expression using the integrated rate law. For first order reaction, K is equal to 1 by T ln. So here we are talking about pressure. So the initial pressure of the reactant divided by the partial pressure of the reactant at some time. So here the reactant is A. That's why I have mentioned A here. So this is the expression for rate constant for this given reaction. So if you check the options, P naught and PA is not mentioned. Instead, P infinite and PT is mentioned. So the meaning is you have to convert this P naught and PA in terms of this PT and P infinity. So let us see the conversion. So the given reaction is A gives B plus C. So the stoichiometric coefficient is 1 for the reactant as well as the products. So they are telling that the reaction was started with the reactant A only. It means that at time t equal to 0, only reactant A will be there. Products are not at all formed. So here we are talking about pressure. So the pressure of the system will be the pressure exerted by A alone. So let us keep that as P naught. So P naught is the initial pressure exerted by A. Then time t equal to T, that is after some time, the partial pressure of A will be reduced by X, and the partial pressure of B will become X. So as the products are formed, the partial pressure increases, so only it is positive. As the reactant decreases, concentration decreases for the reactant, so we have to mention minus. So at time t equal to infinite, so at infinite time, the reaction is fully completed. So the reactant A will be 0, concentration of reactant A is 0, and products are fully formed. So the concentration, that is the pressure of B is P naught and C is also P naught because they have the same coefficient. Now in question, what is given? The total pressure of the system at time t equal to infinite is P infinity. So how will you find the total pressure? So the pressure is exerted by the products only, no? So you have to add that P naught plus P naught will be equal to this total pressure P infinity. So when you add this, 2 P naught equal to P infinity. So what will be the value of P naught? P naught equal to P infinity divided by 2. So this is the value of P naught. So the numerator we have converted in terms of P infinity. Now we have to convert PA. So what is PA? partial pressure of A at some time. So after some time, what is the partial pressure of A? We already got the expression P naught minus X. But you have to know the value of X, no? How to find the value of X? So in question, additional information is given. At time t, the partial pressure exerted, that is, the total pressure exerted is Pt. So when you add all these terms, you have to get Pt. Let us see that. So the total pressure at time t is Pt. How will you get that? You have to add all these terms. P naught minus X plus X plus X. So here only you are having minus X. All the other terms you have to add. So let us cancel minus X and plus X. So Pt is equal to P naught plus X. So how will you find the value of X? X is equal to Pt minus P naught. So this is the value of X. We already got the value of P naught. So what is P naught? P infinity divided by 2. So let us substitute that. X is equal to Pt minus P infinity divided by 2. So this is the value of X. But we want the value of Pa. So how will you find Pa? Pressure, partial pressure of A after some time is, we have given the expression P naught minus X. What is P naught? P naught is P infinity divided by 2 minus X. What is the value of X? So we got the value of X. It is Pt minus P infinity divided by 2. So I will continue in the next page. So Pa is equal to P naught minus X. P naught value is P infinity divided by 2. And what is the value of X? Pt minus P infinity divided by 2. So when you take the bracket, it will become minus Pt, and minus of minus will become plus P infinity divided by 2. So when you add these two, you will get 2P infinity divided by 2 minus Pt. So it will become P infinity minus Pt. So this is the value of Pa. Pa is equal to P infinity minus Pt. So now you have to substitute the value of P naught as P infinity minus 2. So let us see the substitution. K is equal to 1 by T ln P naught divided by Pa. K is equal to 1 by T ln P naught is P infinity divided by 2 whole divided by Pa. Pa is P infinity minus Pt. When you solve this, when you simplify this 2 will go to the denominator. P infinity divided by 2 into P infinity minus Pt. So this is your answer. So let us see the correct option. So the answer is P infinity divided by 2 P infinity minus Pt. So the correct option is option C. The next question is, for the reaction A gives products, a graph is given in which T half and concentration of the reactant is given, and if you see the graph, it is a straight line. So it shows that T half is directly proportional to the initial concentration. So they have a direct relationship. That is, if the concentration of the reactant increases, then the half-life time also increases. So this shows that this reaction is zero order, because in zero order reaction only, we are having T half equal to concentration of the reactant divided by 2K. 2K is constant. So T half is directly proportional to A naught. So here in y-axis, T half is given, and in x-axis A naught is given. So y is directly proportional to x. So y equal to mx. So here the m represents the slope. And if you compare this equation y equal to mx with T half equal to A naught by 2K. So I write here T half equal to concentration of A naught by 2K. So we can also write this as 1 by 2K into concentration of A naught. So here the slope represents what? So the slope represents 1 by 2K. So all the other terms are same. So the slope value is given as 76.92. So 76.92 is equal to 1 by 2k. So we can find the value of k, rate constant. K is equal to 1 by 2 into, take this 76.92 to the denominator, 76.92. So this is the rate constant value. So what is the question? The concentration of A at 10 minutes. So the time should be taken as 10 is dash into 10 power minus 3. The reaction was started with the 2.5 mole liter inverse of A. So the initial concentration A naught is given as 2.5. So you have to find the concentration of A after the time 10 minutes. We know the integrated rate law for the zero order reaction. For zero order reaction, the integrated rate law is K is equal to concentration of A naught minus the concentration of A at some time divided by T. So when you rearrange this equation, you can find the concentration of the reactant at any time. That is A is equal to concentration of A naught minus KT. So let us substitute all these values. So A naught value is 2.5 minus K value is, we have found as 1 divided by 2 into 76.92 into the time T is taken as 10. So when you solve this, you will get 2.5 minus, so when you solve this, you will get as 0.065. So the final answer is, you have to subtract 2.5 from 0.065, you will get 2.435. So the answer is 2.435, but here the answer should be in 10 power minus 3. So it is 2435 into 10 power minus 3 mole liter inverse. So this is the answer. The next question is, in a reaction A plus B gives C, initial concentrations of A and B are related as A naught equal to 8 B naught. So it is given that concentration of A naught equal to 8 into concentration of B naught. So when you take this B naught to the left hand side, concentration of A naught divided by concentration of B naught is equal to 8. So let us keep this respectively. If they start to disappear at the same time, both following first order kinetics. So here it is mentioned as first order kinetics, and their half-life is given 10 minute and 40 minute. Half-life is equal to 0.693. That is, we can write this as ln 2 divided by rate constant K. So here two reactants are there. So first let us take Ka. So we can find Ka using this. Rate constant of A is equal to ln 2 divided by, the half-life of A is 10. So divided by 10. Then rate constant of B is equal to ln 2 divided by, the time is given as 40. So let us keep this. So they are telling that if they start to disappear at same time, after how much time will the concentration of both the reactants be same? So the concentration of both the reactants after some time should be same. So let us assume concentration of reactant A after some time is AT, and that is equal to concentration of reactant B after some time. So we know the first order rate law, K is equal to 1 by T ln of A naught by AT. So this is concentration. So you just take this T to the left hand side. KT is equal to ln of A naught divided by AT. So you have to remove this ln. So for that, you have to raise on both the sides to the power of E. E power KT is equal to concentration of A naught divided by concentration of AT. Now let us take the reciprocal. E power minus KT is equal to concentration of AT. So I have taken the reciprocal divided by concentration of A naught. So what will be the concentration of AT? AT is equal to, take this to the left hand side, concentration of A naught into E power minus KT. So I hope you understood this derivation. So let us write that here. You have to remember this formula. So concentration of A naught E power minus KT is equal to concentration of B naught. For BT also we can write like this, E power minus KT. So you have to be specific with rate constant. So it is KAT, and in right hand side it is KBT. Now we have to simplify this. Take this B naught to the left hand side. So concentration of A naught divided by concentration of B naught is equal to, take this E power minus KAT to the right hand side. So it is e power minus kBt divided by e power minus KAT. So when you simplify this by taking this to the numerator, you will get e power minus kBt plus KAT. So you can take the t in common also. So this Ka term is positive. So we can write this as Ka minus Kb into T. Now if you see the left hand side, it is concentration of A naught divided by concentration of B naught. So already in question itself it is given as 8. So 8 equal to e power Ka minus Kbt. Now we have to take this e power on the right hand side. So taking natural logarithm on both sides. So left hand side will become ln 8 equal to Ka minus Kb into T. So ln 8 we can write as ln of 2 cube is equal to, then in right hand side we are having Ka. Ka value we have already found as ln 2 divided by 10 minus Kb value we have found as ln 2 divided by 40 into time. So now we can write this ln 2 cube as 3 ln 2 is equal to, now you have to take the LCM for the right hand side. So the LCM is 40. So now you have to multiply the first term by 4. So 4 ln 2 minus ln 2 into time. So 3 ln 2 is equal to 4 ln 2 minus ln 2 is again 3 ln 2 divided by 40 into time. So this 3 ln 2 will get cancelled. Taking the 40 to the left hand side, you will get the answer. Time t is equal to 40 and the unit is minutes. So the correct option is option D. Half-life of a zero order reaction A gives product is 1 hour. When initial concentration of reaction is 2 moles per liter, the time required to decrease concentration of A from 0.50 to 0.25 moles per liter is. So the half-life of a zero order reaction is given by the formula T half is equal to initial concentration divided by 2 into K, rate constant K. So the half-life is given as 1 hour. So in options you are also having minute also. So 1 hour is 60 minutes. So from this you can find the rate constant K because A naught value, that is the initial concentration, is also given. So let us substitute this. K is equal to initial concentration divided by 2 into T half. So K is equal to initial concentration is 2 divided by 2 into T half is, we have found as 60 minutes, 60. So this 2 will get cancelled. So the rate constant is 1 by 60. So let us keep this. So here they are asking the time required to decrease the concentration of A from 0.50 to 0.25. So we know the integrated rate law for zero order reaction. K is equal to concentration of A naught minus concentration of A at some time AT divided by T. So you have to find the time required they are asking. So rearrange this. T equal to A naught minus AT divided by K. So now you have to take the A naught value. So two values are given now. So these two values only you have to take. So the A naught value here you have to take is 0.5 minus AT value is 0.25 divided by rate constant K we have found 1 by 60. So the answer is 0.5 minus 0.25 is 0.25 and this 60 is denominator of denominator. It is present as denominator of denominator. So it will become numerator. So it will come into the numerator. So 0.25 into 60. When you multiply this, you will get 15. So when you multiply this, the answer is 15 and the time we have measured in minutes now. So the answer is 50 minutes. 15 minutes. So the correct option is option C. In a first order decomposition reaction, the time taken for the decomposition of reactant to 1/4 and 1/8 of its initial concentration are T1 and T2 respectively. The ratio of T1 by T2 will, so here the ratio is given. So let us assume the initial concentration of the reactant is A naught and 1/4 of the initial concentration is A naught by 4. Then 1/8 of the initial concentration is A naught by 8. So the rate law, the integrated rate law for first order decomposition, KT KT equal to ln of concentration of A naught by concentration of A. So here for 1/4, the time is T1. So KT1 is equal to ln of A naught divided by, here A is the 1/4 concentration, that is A naught by 4. Concentration of A naught divided by 4. So A naught will get cancelled. This 4 is denominator of denominator. It will go to the numerator. Therefore, KT1 is equal to ln of 4. So in similar way, we can write for the 1/8 concentration, KT2 is equal to ln of A naught divided by 8. So the A naught will get cancelled. 8 will go to the numerator. So KT2 is equal to ln 8. So let us divide these two equations. KT1 equal to ln 4. So you have to divide this by the second equation. KT2 equal to ln 8. So K will get cancelled. T1 by T2 is equal to ln 4 is given. You can write this as ln of 2 square. 4 is 2 square. Then ln 8 is given. It is ln of 2 cube. So we know that ln of A power B is equal to B ln A. So we can write this as 2 ln 2 divided by, here the power is 3. 3 ln 2. So the ln 2 will get cancelled. So T1 divided by T2 is equal to 2 divided by 3. So the correct option is option D, 2 by 3. Which of the following graphs most appropriately represents a zero order reaction? So we know the integrated rate law for zero order reaction. Concentration of A is equal to concentration of A naught minus KT. So if we plot a graph for this equation, then concentration of A will be in the y-axis, then time will be in the x-axis. So the graph will be a straight line with the negative slope. So that negative slope gives the rate constant K. So here the graph is plotted for a zero order reaction for concentration, that is the reactant concentration and time. So you have to check in which option the reactant concentration and time is given. So the correct option is option A. So in option A only reactant concentration and time with the negative slope is given, that is straight line with negative slope. In option C, the concentration is constant, so that is wrong. In option B, rate is given, rate versus time. In option D also rate versus time is given, so that is wrong. So the correct option is option A. For a bacterial growth in a cell culture, growth law is very similar to the law of radioactive decay. We know the law of radioactive decay, N equal to N naught e power minus KT. So the bacterial growth, it is related to this law of radioactive decay as N equal to N naught e power KT. So in first equation, that is law of radioactive decay, so this is decay, you are having e power minus KT, and in second equation, this is for the bacterial growth, you are having e power KT. So when you rearrange this, you will get N by N naught equal to e power KT. So when time t equals to 0, then it will become N by N naught equal to e power 0, that is 1. So it tells that the growth is exponential. So there is an exponential increase and it starts with 1 and it rises sharply as time progresses. So let us see the 4 options. So in option A, so a negative slope straight line is given. So option A is wrong. In option B, decay is given. So this is exponential decrease. So option B is also wrong. So in option C, so first there is a increase, but it starts from 0. So as I told, at time t equal to 0, the growth is 1. So it should not start from the origin. So the option C is also wrong. And also first it increases, then it becomes constant. So it is wrong. Now in option D only, it starts from 1, then there is a sharp increase. So option D is the correct option. The next question is, consider an elementary reaction A plus B gives C plus D. If the volume of the reaction mixture is suddenly reduced to 1/3 of its initial volume, the reaction rate will become x times of the original reaction rate. The value of x is, so in question it is given an elementary reaction. So for an elementary reaction, rate is given by rate equal to rate constant into concentration of the reactants, and it is first order with respect to both the reactants. If the volume of the reaction mixture is suddenly reduced to 1/3, so the initial volume is V, and after the reduction, let us assume it is V dash. So V dash equal to 1/3 V. We have written concentration in this rate equal to rate constant into concentration of A, concentration of B. So what is actually concentration? It is number of moles divided by volume. So number of moles of A by V, then number of moles of B divided by V. Volume is same for both. So they are telling that the volume is reduced. So before the reduction, what is the rate? So the rate K equal to Na into Nb divided by V square. So let us keep this as R1. So now after the reduction of volume, R2 is equal to K into Na into Nb divided by, so the volume is 1/3 of the initial volume, the whole square. So when you take the square, K Na Nb divided by 1/3 will become 1/9, then V square. This 9 is denominator of denominator, so when it goes to the numerator, we will get the rate as R2 equal to 9 K Na Nb divided by V square. So this is R2 equal to 9 into R1. So this whole term is nothing but, R1. So R2 is 9 times of R1. So the reaction rate will become x times of the original reaction rate. So the value of x is C, 9. The next question is, which of the following statement is not true for radioactive decay? Decay constant increases with increase in temperature. This first statement is not true because radioactive decay, it is a nuclear process. It is not a chemical process, it is a nuclear process. It does not require activation energy. It does not require any activation energy, EA. So this decay constant is independent of external factors. It is independent of temperature, pressure. So decay constant increases with increase in temperature is wrong. It is not true. So the first statement is the correct option. So let us see the other statements also. Amount of radioactive substance remained after 3 half-lives is 1/8 of original amount. How to find the amount of radioactive substance after n half-lives? So this radioactive decay follows first order kinetics. So the amount of substance remaining after n half-lives is given by the formula n equal to n naught into 1/2 whole power n. So n stands for the number of half-lives. Here n naught is the initial amount. So n stands for the number of half-lives. Here n is 3, n equal to 3. So the amount of substance equal to the initial substance into 1/2 power 3, which is nothing but n naught divided by 2 power 3 is 8. So it is 1/8 of the original amount. So it is correct. Decay constant does not depend upon temperature. Third statement is also correct. So we already explained in the first option itself. Half-life is ln 2 times of 1 by rate constant. So we already told it follows first order kinetics. So we know the half-life formula, T half is equal to ln 2 divided by rate constant for a chemical equation. But radioactive decay is a nuclear process. So T half equal to ln 2 divided by lambda. This is the decay constant. So the decay constant is the rate constant for the nuclear process. So the fourth statement is also correct. So the correct option is option 1. The next question is, A gives B. The molecule A changes into its isomeric form B by following a first order kinetics at temperature of 1000 Kelvin. If the energy barrier with respect to reactant energy for such isomeric transformation is 191.48 kilojoule per mole inverse and the frequency factor is 10 power 20, the time required for 50% molecules of A to become B is. First, in this question, what is asked? The time required for 50% molecules of A to become B. So 50% of reactant to become the product is half-life. So you have to find the half-life of this reactant. So they told that it is a first order reaction. So in first order reaction, half-life is equal to ln 2 divided by K, rate constant. So you need to find the half-life. For that, you have to know rate constant K. So how to find the rate constant? Here, information is given in this question. Temperature. Temperature is given as 1000 Kelvin. The energy barrier with respect to reactant energy, that is the activation energy EA, is given 191.48 kilojoule per mole inverse, and the frequency factor A value is given 10 power 20. So we know the Arrhenius equation. K, rate constant, is equal to A e power minus EA divided by RT. So you have to find the rate constant. A value is 10 power 20, e power minus EA value 191.48 kilojoule is given. So it is into 10 power 3 divided by R, gas constant value 8.314 into temperature is 1000. So first you have to solve this. So when you solve this, you will get e power minus 23.031. So this is the value you will get. So we know that ln 10 value is 2.303. Here we are having 23.03. So how we can write this with the known terms? Rate constant equal to 10 power 20 e power minus ln 10 into 10. So ln 10 value is 2.303 into 10 will give you 23.03. So we have rearranged this as ln 10 into 10. So here you are having e power minus ln 10. So e power ln you can write as 10, and in power you are having another term 10. So this e power ln 10 can be written as 10, and in power you are having another term, no, another 10 is there, and minus is also there. So 10 power minus 10. So K is equal to 10 power 20. 10 power minus 10 can be written as in denominator 10 power 10. So when you solve this, or just like that, you can subtract. So it is 10 power 10. So the rate constant value is 10 power 10. So this is the rate constant. Now in question you have to find the time required for 50% molecules of A to become B, that is T half. So T half is equal to ln 2 is there. So ln 2 is nothing but 0.693 divided by K value we have found as 10 power 10. So this 10 power 10 will go to numerator. So T half is equal to 0.693 into 10 power minus 10. So that's all. But here they are asking to find the answer in picoseconds. Pico is 10 power minus 12. We got the answer in 10 power minus 10. So I will write here. T half value we got is 0.693 into 10 power minus 10. So now you have to multiply and divide by 100. So when you multiply this number by 100, it will become 69.3. And when you divide, the power will go to this 10 power. So it will become 10 power minus 12. So they are asking the nearest integer. So T half is equal to 69 into 10 power minus 12. So pico is already given. So the answer is 69. So this is the answer. The next question is, for the thermal decomposition of N2O5 at constant volume, the following table can be formed for the reaction mentioned below. 2N2O5 gives 2N2O4 plus O2. So the equation is given. 2N2O5 gives 2N2O4 plus O2. So for this equation, at time 0, the total pressure is 0.6. At time t equal to 0, we know that only the reactant is present. So you don't see the coefficient and all. For the reactant, the initial pressure is P naught. The products are not at all formed. So you have to keep it as 0. They are telling the total pressure at the time is 0.6. How will you find the total pressure? You have to add this. So when you add this, you will get 0.6. So it is clear that in this equation, only P naught is present. So we can write that P naught equal to 0.6. So we can come to this conclusion from this first row. So we are going to the second row. At time t equal to 100, the total pressure is x. So let us assume that the time is t. So after some time, the reactant will decrease. So the partial pressure exerted by the reactant will also decrease. Here the coefficient is 2. So from the initial pressure, the reactant will decrease 2 times the reactant pressure. So let us keep it as 2 small p, because already x is given here. So let us use small p. Then the product partial pressure increases. Here the coefficient is 2. So let us keep 2p. So it increases by 2p, and here the coefficient is 1. So it increases by p. So now the total pressure is x. So now let us just keep this as x. So how will you find the total pressure? You have to add all these terms. So P naught minus 2p and plus 2p will get cancelled. So I will write the equation first. P naught minus 2p plus 2p plus p equal to x, which is given in the question. So how will you find the equation? The 2p will get cancelled. So P naught plus p equal to x. So from this we can find the value of small p. The difference we can find. So the small p value is equal to x minus P naught. So in this case, x refers to the total pressure. So that you have to keep in mind. So x refers to the total pressure at time 100. So here the time is 100. Now we found the small p value, no? So what will be the partial pressure of the reactant at time 100? So how will you find that? Partial pressure of the reactant N2O5 at t equal to 100. We already wrote the equation P naught minus 2p. So it is P naught minus 2p. So just to substitute the value of small p. Small p is 2 into x minus P naught. So P naught minus 2x. So minus into minus will become plus 2p naught. So P naught plus 2p naught will become 3p naught. 3p naught minus 2x. So this is the pressure of N2O5 at t equal to 100. Now rate constant is given. So from this we can find the x value. Here the rate constant is having the unit second inverse. So it is clear that, and we already know that the decomposition of N2O5 follows first order kinetics. So in first order kinetics, rate constant is equal to 2.303 divided by t log of A naught. In this case, you have to use P naught. P naught divided by P A. A is the reactant, so P N2O5. So just take these terms to the left hand side. K value is given 4.606. So 4.606 into 10 power minus 2 into t will come. So the time is 100. So time is 100 divided by this 2.303 will go to the denominator. So divided by 2.303 is equal to log of P naught divided by P N2O5. We have found out here P N2O5 3p naught minus 2x. So you have to solve this. So 10 power minus 2 and 100 will get cancelled. 4.606 divided by 2.303 is 2. So in left hand side you are having 2 and in right hand side you are having log of P naught value is 0.6. Log of 0.6 divided by 3 into P naught. 3 into 0.6. So it is 1.8 minus 2x. You have to find the value of x. So you have to remove log from the right hand side. So you have to raise everything to the power of 10. So the left hand side will become 10 power 2. And when you raise the right hand side to the power of 10, the log will get cancelled. So you will get 0.6 by 1.8 minus 2x. So just take reciprocal. So 1 by 100 will become 0.01 equal to 1.8 minus 2x divided by 0.6. So when you solve this, you will get the answer as 1.8 minus 2x equal to 0.6, and this 0.01 will give 0.006 minus 2x equal to 0.006 minus 1.8. So x value is equal to 1.794 divided by 2. So the x value is 0.897. So finally we got the x value equal to 0.897. Here the answer should be in 10 power minus 3. So multiply and divide by 1000. So when you multiply by 1000, the answer will become 897, and this 1000 can be written as 10 power minus 3. So the answer is 897 into 10 power minus 3. So this is the answer. The next question is, for a given reaction R gives P, T half is related to A naught as given in table. If the initial concentration is 0.1, then the half-life will be 200 minutes. If the initial concentration is 0.025, then the half-life is 100. Which of the following is true? The order of the reaction is 1 by 2. So we need to find the order of the reaction. For any reaction, the half-life is related to the initial concentration of the reaction by this formula. T half is proportional to concentration of the reactant power 1 minus N. Here N stands for order of the reaction. So we need to find the N value. So to remove the proportionality, we have to introduce the constant. But here we are already having two values of A naught and the T half. So we can substitute that. So first let us take the T half 200 value divided by 100. So now we can write the equal to sign, and the proportionality constant will be cancelled, and the A naught value is 0.1 divided by 0.025 whole power 1 by N. So when you solve this, you will get 2 equal to, when you solve this, you will get 4 power 1 minus N. So in left hand side we are having 2, and right hand side 4 we can write as 2 power 2 whole power 1 minus N. So you have to multiply the powers. So this will become 2 power 2 into 1 minus N. So the base is same. So we can equate the powers. So here you are having 2 power 1. So equating the powers 1 equal to 2 into 1 minus N. So taking this 2 to the left hand side, 1 by 2 equal to 1 minus N. So when you solve this, take the N to the left hand side. Minus N will become plus N. And take this 1 by 2 to the right hand side. Already you are having 1. 1 minus 1 by 2. So it will become 1 by 2. 1 minus 1 by 2 is 1 by 2. So N is order. Already I told that N is the order. So the N value is 1 by 2. So the first option is correct. Now the second option, if A naught is 1 M, then T half is 200 root of 10 minutes. So let us check that. You have to do in the same manner. So the T half is proportional to concentration of A naught power 1 minus N. So we got the N value 0.5. So let us see in the next page. So if the concentration of A naught equal to 1 M, then what is the T half value? So already we are having the table. If the concentration is 0.1, then the T half is 200. So we can take this. So T half when the concentration is 1 M divided by T half when the concentration is 0.1 M is equal to concentration of A naught divided by, so when the concentration is 1 M divided by the concentration, that is 0.1 M whole power 1 minus N. So N value we got as 0.5. So 1 minus 0.5 is nothing but 0.5. So let us substitute the values. You have to find the numerator T half when concentration is 1 M divided by T half when it is 0.1 For 0.1, the T half is 200. So divided by 200 equal to, so here you are having the concentration 1 divided by 0.1 into 1 by 2. So T half is equal to, so taking the 200 to the right hand side, 200, then you are having 1 by 0.1. So it is multiplied by 10, 10 power 1 by 2. So 1 by 2 is nothing but square root. So the second option is also correct. If A naught is 1 m, the T half is 200 root 10. So second option is also correct. So let us go to the third option. The order of the reaction changes to 1 if the concentration of the reactant changes from 0.1 to 0.5 m. Here they are telling the order of the reaction changes. So when the concentration of the reactant increases, only the rate of the reaction changes. Rate of reaction changes. The overall order of the reaction does not change. And that too, in a first order reaction, concentration of reactant does not play any role, because in a first order reaction, T half is equal to ln 2 divided by rate constant. So here the value is a constant. It does not change with the concentration of the reactant. So the third statement is not true. Going to the fourth statement. T half is 800 minute for A naught is 1.6 m. So this D is same as B, option B. You have to find in the same manner. So let us see that. So when T half is 1.6 for a 1.6 m, you have to find that. So let us take the same T half of 0.1 m is equal to concentration of A naught, that is 1.6, divided by concentration of A naught, that is 0.1. So let us substitute the value. So T half of this 1.6 m you have to find, divided by, for 0.1 m the T half value is 200, is equal to 1.6 divided by 0.1, and here you are having the order 1 minus n. So 1 minus 0.5 is 0.5. So when you substitute, T half is equal to, take this 200 to the right hand side, 200 into, so 1.6 divided by 0.1 is 16, and 0.5 is nothing but 1 by 2. So 1 by 2 is square root. So T half equal to 200 into square root of 16 is 4. So T half equal to 200 into 4 is 800 minute. So the fourth option is also correct. So option 4 is also correct. So the true statements are A, B and D. So the correct option is option 2. Drug X becomes ineffective after 50% decomposition. So 50% decomposition means we can tell that after the half-life of this drug X, the drug becomes ineffective. The original concentration of drug in bottle was 16 milligram per milliliter, which becomes 4 milligram per milliliter in 12 months. So the expiry time of the drug in months is, assume that the decomposition of the drug follows first order kinetics. So the expiry time of the drug means you have to find the T half, because after the half-life of this drug X, so the drug becomes ineffective. So 50% decomposition is nothing but T half. So how to find the T half for a first order reaction? T half equal to ln 2 divided by K, rate constant. How to find the rate constant for a first order reaction? Rate constant equal to 1 by T ln of initial concentration divided by concentration of the reactant at time T. So rate constant equal to, so at time 12 months, they are telling no, so 1 by 12 ln of A naught. A naught is 16. So numerator is 16 and AT is 4. So K equal to 1 by 12 ln of 16 by 4. Ln of 16 by 4 is 4. So this is the rate constant value. So with this we can find the T half. T half equal to ln 2 divided by rate constant. Rate constant value is 1 by 12 ln 4. So this 12 is present as denominator of denominator. So it will go to the numerator. T half equal to 12 into ln 2 divided by ln 4 we are having. So we can write ln 4 as ln 2 square. So the next step is T half equal to 12 into ln 2 divided by, so the power will become as 2 into ln 2. So ln 2 will get cancelled. So the answer is 12 divided by 2 is equal to 6. So here they are telling the time in months. So the answer is 6 months. So option 2 is the correct answer. The next question is, given below are two statements. Statement 1. The rate law for the reaction A plus B gives C rate equal to K concentration of A power 2 concentration of B. When the concentration of both A and B is doubled, the reaction rate is increased X times. So the rate of the reaction is given rate equal to K concentration of A power 2 into concentration of B. If the concentration is doubled, then A dash becomes 2A and B dash become 2B. So the new rate R dash is equal to K 2A whole square 2B. So R dash is equal to K 2 square is 4. 4 into A power 2. Then here you are having 1 2. 2 into concentration of B. So R dash is equal to 4 into 2 is 8. 8 K A power 2 into concentration of B. So the new rate is increased X times. So the value of X is 8. So the value of X is 8. So the new rate is increased 8 times. Statement 2. The figure is showing the variation of concentration against the time plot for a Y order reaction. So the given graph is a straight line with negative slope, and it is showing the plot for concentration versus time. So only for a zero order reaction, we have the plot of concentration versus time with the negative slope. And for a first order reaction, the plot is between ln of concentration of the reactant versus time. But here we are having only the concentration, so the order of the reaction is zero order reaction and it is not first order reaction. So here they are telling it is Y order reaction, so the value of Y is 0. So the question is the value of X plus Y is, so value of X is 8, value of Y is 0, X plus Y equal to 8 plus 0 equal to 8. So the answer is 8. Consider the following first order gas phase reaction at constant temperature. So the equation given is A gives 2B plus C. If the total pressure of the gases is found to be 200 torr after 23 seconds and 300 torr upon the complete decomposition of A after a very long time. So for a first order reaction, the complete decomposition occurs at time infinity. So now the question is, then the rate constant of the given reaction is. So how will you find the rate constant for a first order reaction? Rate constant equal to 2.303 divided by time into log of, so here we are talking about pressure, initial pressure of the reactant divided by pressure of the reactant after some time. So this is the formula. So with the given information, at time t equal to 0, only the reactant will be present. So the partial pressure exerted by the reactant is P naught. It is the initial pressure. The products are not at all formed. Then at time t equal to 23 second, t equal to 23, or you can say at some other time t equal to t, the partial pressure of the reactant will be decreased X times and the partial pressure of the product B will be increased 2X times, and for C it is increased by X times. So let us keep this time as 23. So we don't know the value of X. We need to find that. Now they are telling that complete decomposition. So complete decomposition means infinite time the reactant A is completely decomposed. So it is not present. So there is no pressure exerted by the reactant A. Then that pressure, partial pressure exerted by B is 2 P naught, 2 times the initial pressure exerted by A, and for C it is P naught. Now after the complete decomposition the total pressure is 300 torr. So when you add this you will get the total pressure 300 torr. So with that you can find P naught value. So 3 P naught equal to 300 torr. So when you divide that, P naught equal to 300 divided by 3, which is equal to 100. So the value of P naught is 100 torr. Now another information is also given. After 23 seconds, the total pressure of the system is 200 torr. So this is the time we mentioned as 23. So the total pressure is equal to 200 torr. So when you add this, you can find the value of X. So let us see the calculation. So I will write it here. P naught minus X plus 2X plus X. So plus 2X plus X equal to 200. So minus X and plus X will get cancelled. So P naught plus 2X equal to 200. 2X equal to 200 minus P naught. Already we got the value of P naught as 100. So let us substitute the value of P naught 100. So 2X equal to 100. So what will be the value of X? X is 100 by 2, 50 torr. So we got the value of X. Now we can find the partial pressure of reactant A at time 23 seconds. So let me erase this. So let us find the partial pressure of the reactant A at 23 seconds. So you have to find using this formula P naught minus X. So partial pressure of A equal to P naught is 100. 100 minus, we got the X value we got 50 torr. So 100 minus 50, so which is equal to 50 torr. So now we can substitute these values for finding rate constant K. K equal to 2.303 divided by T. Time is 23 seconds. So divided by 23 into log of P naught. P naught value is 100. 100 divided by PA. PA value is 50. So rate constant equal to 2.3 divided by 23 will become 0.1. Log of 100 by 50 is 2. K equal to 0.1 into log 2 value is 0.3010. So when you multiply this, you will get 0.03010. So the answer should be in 10 power minus 2. So bring the decimal point in front of 2 digits. So the answer is 3.01 into 10 power minus 2 second inverse. So the answer is 3.01 into 10 power minus 2. Consider the following reaction. A plus B gives C. The time taken for A to become 1/4 of its initial concentration is twice the time taken to become 1 by 2 of the same. So for the reactant A to become A by 2, so the concentration of A to become half of the concentration, we know the time taken is T half. The same to become 1 by 4th of its concentration, we know the time taken is T 1 by 4. So in this question, what is the information given for that 1 by 4th of the initial concentration? So the time taken for the concentration to become 1 by 4th is equal to twice the time taken to become 1 by 2. So T 1 by 4 equal to 2 into T 1 by 2. So now we are going to compare this with zero order reaction and the first order reaction. So let us see that. So for a first order reaction, we know that T half equal to ln 2 divided by K. T 1 by 4 is equal to ln 4 divided by K. So the formula is for T 1 by 4, the formula is ln 4 by K. So we can write ln 4 as ln of 2 square, no? So the power will go to the front. So 2 into ln 2. We can write like this. So T 1 by 4 is equal to 2 into ln 2 divided by K. So already at first we wrote that what is ln 2 by K? Ln 2 by K is T half. So we can substitute that. So T half is equal to 2 into, sorry, T 1 by 4 equal to 2 into, so T 1 by 4 is equal to 2 into T half. So this is what is given in the question also. So now we can tell that A is first order. So the order of the reactant A is first order. We can also check with zero order also. So the half-life of a zero order reaction, it depends on the initial concentration of the reactant. So concentration of A naught divided by 2K. The T 1 by 4 of a zero order reaction is concentration of A naught divided by 4K. So how we can write this? 1 by 2 into concentration of A naught by 2K. So which is equal to 1 by 2 into T half. So for a zero order reaction, the time taken to become 1 by 4th of the initial concentration is half of the time taken to become 1 by 2 of the same. So it is not twice, it is half. So it is not a zero order reaction. It is a first order reaction with respect to A. The next part of the question is, when the change of concentration of B is plotted against time, the resulting graph gives a straight line with a negative slope and positive intercept on the concentration axis. So for the reactant B, we are plotting the graph between concentration and the time. So we get the graph as straight line with the negative slope. So we know that for a zero order reaction only, we plot the graph for concentration and time. So for B, for the reactant B, it is zero order reaction. Now the question is, the overall order of the reaction is. So the rate law for this equation is rate equal to rate constant into concentration of A power X. So for the reactant A, the order is 1 and the concentration of B power Y. So for the reactant B, the order is 0. So the overall order is equal to X plus Y. That is 1 plus 0, which is equal to 1. So the overall order is 1. For a reaction A gives B gives C, if the rate of formation of B is said to be 0, then the concentration of B is given by. So in this reaction, first the reactant A gives the product B. Then this B decomposes to give C. So in this question itself, two rate constants are also given. So they are telling if the rate of formation of B is said to be 0. So how will you write the rate of formation of B? So first take this equation A gives B, rate of formation of B is equal to, as it is in the product side, so it will be positive only. So change in the concentration of B, that is increase in concentration of B divided by dt. So in this question, two rate constants are given. So for this you can write the rate law. So for the first equation, A gives B, rate constant is K1. So this is the rate of formation of B. So the rate R1 is equal to K1 into concentration of A. Then the next equation, B gives C, the rate constant is K2. So you can write the next rate law, R2 is equal to K2 into concentration of B. So we are having two different rate laws for this equation. Now here we have written rate of formation of B as rate of change of the concentration of B by the change in the time. So this is nothing but rate of change in concentration. Now, from this equation, it is clear that how the change in concentration of B occurs. First, B is formed. So, this is the rate of formation of B. R1 is the rate of formation of B. And then B is consumed to give C. So, R2 is the rate of consumption of B. So, as B is consumed to give C, this rate with respect to B will be negative. So, we can write the rate of change of concentration as dB by dt is equal to, first it is formed. So, R1, that is K1 into concentration of A. So, first how the change is occurring, first it is formed, B is formed. So, the first rate law is K1 into A. Then how it is consumed by giving C. So, it is negative minus K2 into B. So, from this you can find the concentration of B. Because in question it is given that rate of formation of B is said to be 0. So, the rate of formation of B is 0, which is equal to K1 into concentration of A minus K2 into concentration of B. So, take this K2 into concentration of B to the left hand side. So, K2 into concentration of B is equal to K1 into concentration of A. So, take this K2 to the right hand side. So, the concentration of B is in the left hand side. Concentration of B is equal to K1 divided by K2 into concentration of A. So, the correct option is option D. Next question is, NO2 required for a reaction is produced by decomposition of N2O5 in CCl4 as by equation. 2N2O5 gives 4NO2 plus O2. So, in this equation, you have to see the reactant N2O5 and the product NO2. So, for this equation, you can write the rate of the reaction. So, we know that rate of disappearance of N2O5 should be equal to rate of formation of NO2. So, the rate of disappearance of NO2 is given by negative value minus change in concentration of N2O5 divided by change in time. And here you are having the coefficient 2. So, you have to multiply by 1 by 2. So, rate of disappearance of N2O5 is minus 1 by 2 into change in the concentration of N2O5 by the change in time, which is equal to formation of NO2. Here the coefficient is 4. So, it is a positive value. So, 1 by 4 into change in concentration of NO2 divided by change in time. So, in this question, what they are asking us to find? The initial concentration of N2O5 is 3 mole per liter and it is 2.75 moles per liter after 30 minutes. The rate of formation of NO2 is x into 10 power minus 3 mole per liter inverse minute inverse. Value of x is. So, here you have to find the rate of formation of NO2. So, we are having the formula to find the rate of formation of NO2. So, let us rearrange in that way. So, the rate of formation of NO2 is, take this 4 to the left hand side. So, the rate of formation of NO2 is change in concentration of NO2 divided by change in time. This is the rate of formation of NO2, which is equal to, we are taking the 4 to the other side. So, 4 into, then already we are having minus 1 by 2 into rate of change of concentration of N2O5 by the concentration of time. So, how to find the formation of NO2, rate of formation of NO2? You need to know the values of this term. So, with that you can find. So, in this question, the change in concentration of N2O5 is given. So, how will you find the change in concentration? So, the change in concentration of N2O5 is equal to final concentration minus initial concentration. So, the final concentration is 2.75 minus initial concentration is 3. So, when you subtract this, the change in concentration is minus 0.25 moles per liter inverse. So, the value will come in minus 0.25 negative value and the change in time is 30 minutes. So, delta T is equal to 30 minutes. No need to convert it into seconds. Then because here the rate is in minute inverse only, so no need to convert. So, let us substitute these values. So, the rate of formation of NO2 is equal to, you can cancel this and it will become 2. 2 into, already you are having a negative value. So minus, here the change in concentration of N2O5, we got the answer as minus 0.25. So it is minus 0.25 divided by the change in time dt. The change in time is 30 minutes. So d NO2 by dt is equal to 2 into minus will become plus. So 0.25 by 30, which is equal to 2 into 0.25 is 0.50 by 30. So when you solve this, you will get 0.0166 mole liter inverse minute inverse. But the answer is in 10 power minus 3. So take the decimal point after 3 digits. So 16.6 into 10 power minus 3, and here they are asking it in the nearest integer. So 16.6 is, the nearest integer is 17. 17 into 10 power minus 3. So the answer is, so the value of x is 17. Already 10 power minus 3 is given. So the answer is 17 into 10 power minus 3 mole liter inverse minute inverse. The next question is, A gives 2B plus C is a first order reaction. The initial pressure of the system was found to be 800 millimeters of mercury, which increased to 1600 millimeter of mercury after 10 minutes. So the equation given is A gives 2B plus C. So at time t equal to 0, the initial pressure of the reactant is P0. Products are not formed. So they are telling that the initial pressure of the system is 800. So how the pressure is exerted by the system? It is exerted only by the reactant A, because at time t equal to 0, only the reactant A is present. So this initial pressure of the system is 800 mm of Hg. So we can conclude that the initial pressure of A, P0, is equal to 800 mm of Hg. Then what is given? Which is increased to 1600 mm of Hg after 10 minutes. So after some time, t equal to t, after some time, the partial pressure of A decreases x times, and the partial pressure of B increases 2x times, and for C also it increases x times. Now they are telling that at time t equal to 10 minutes, so this P0 minus x plus 2x plus x is equal to the total pressure of the system, that is 1600. So we have to solve this to find the value of x. So let me write this in the next side. So at time t equal to 10, the total pressure is 1600. So how will you get the total pressure? P0 minus x plus 2x plus x equal to 1600. So minus x plus x gets cancelled. P0 plus 2x equal to 1600. 2x is equal to 1600 minus P0. And we got the value of P0 as 800 mm of Hg. So let us substitute that. So 1600 minus 800, which is equal to 800. So value of x is 800 divided by 2, which is equal to 400. So the value of x is 400. So with that we can find the partial pressure of A at time 10 minutes. So let me erase this. So partial pressure of A at any time t is given by the formula P0 minus x. So we found the value of x at time 10 minutes is 400. So let me substitute that. So partial pressure of A at time 10 minutes is P0 minus x, which is equal to P0 value is 800 and x value we got as 400. So PA is equal to 400 mm of Hg. So we got the value of PA, we got the value of P0. So we got the value of P0, we got the value of PA. With that we can find the rate constant for this reaction. So the rate constant for a first order reaction is given by rate constant equal to 2.303 divided by T into log of initial pressure of the reactant by the partial pressure of the reactant at any time. So rate constant is equal to 2.303 divided by T. T is 10 minutes. 10 into log of P0 value is 800 divided by PA value is 400. So which is equal to 2.303 divided by 10 log of 800 by 400 is 2. So we got the rate constant value K is equal to 2.303 by 10 into log 2. So now what is the question? The total pressure of the system after 30 minutes. So we need to find the total pressure of the system after 30 minutes. For that also you need to know the X value. So the X value we got as 400 for 10 minutes. But for 30 minutes, what is the X value? You have to find that. So we can use the same integrated rate law. So the rate constant K is equal to 2.303 divided by, now the time is 30. 30 into log of P naught. P naught value is initial pressure. So it is 800 divided by PA. We don't know the value of PA at 30 minutes. So let us keep that. So now the left hand side, I am going to substitute with this value. So the left hand side will become 2.303 divided by 10 log of 2 is equal to, the right hand side is 2.303 divided by 30 log of 800 divided by PA. So 2.303 will get cancelled and this will become 3. So take this 3 to the left hand side. So I will continue here. So you will get 3 log of 2. So 3 log 2 you can also write as log of 2 cube. So what is 2 cube? 2 cube is nothing but 8. So this 3 into log 2 is now log 8, which is equal to log of 800 divided by PA. So log we can cancel the log. So 8 is equal to 800 divided by PA. So the value of PA is equal to 800 divided by 8, which is equal to 100. So we got the value of PA. Now how to find the total pressure? So I will explain that. First, let me erase this one. So we got the value of PA. PA is nothing but this one. PA is equal to P naught minus X. So what is PA? Now it is 100. 100 is equal to P naught value we already know 800 minus X. So what is the value of X now? At time t equal to 30, what is the value of X? So it is 800 minus 100. So X value is 700. So first we got one X value as 400, no? That is for time 10 minutes. Now for time 30 minutes, the X value is 700. So we got the PA value for this one. So after 30 minutes, the PA value we got as 100. Now we can find 2X. So here X is 700, no? So 2 into 700, which is nothing but 1400. Then X value, again 700. So how will you find the total pressure now? So P total is equal to 100 plus 1400 plus 700. So which is equal to 2200 millimeter of mercury. So the answer is 2200. The next question is KClO3 plus 6 FeSO4 plus 3 H2SO4 gives KCl plus 3 Fe2SO4 tries plus 3 H2O. The above reaction was studied at 300 Kelvin by monitoring the concentration of FeSO4, in which the initial concentration was 10 m and after half an hour became 8.8 m. The rate of production of 3 Fe2SO4 tries is. So in this equation we are talking about the reactant FeSO4 and the product Fe2SO4 tries. So let us concentrate on these two compounds. So in question they are asking the rate of production of Fe2SO4 tries. So in this equation we can write the rate of the reaction is equal to rate of disappearance of FeSO4 and the rate of formation of Fe2SO4 tries. So the rate of disappearance of FeSO4 is given by minus, the coefficient is 6. So 1 by 6 of rate of change of FeSO4, that is the concentration. Rate of the change in concentration of FeSO4 by the change in time, which is equal to the formation of the product. So here the coefficient is 3. So 1 by 3, the change in concentration of Fe2SO4 tries divided by change in time. So for this equation, we can write the rate of the reaction. So we know the rate of the reaction is, that is the rate of the disappearance of the reactant will be equal to the rate of formation of the product. So the rate of this reaction is equal to rate of disappearance of the reactant. So disappearance is represented by the negative sign. Then you are having the coefficient 6. So 1 by 6 into change in concentration of the reactant FeSO4 divided by change in time. So this is equal to formation of the product. Formation of the product is positive. And here the coefficient is 3. So 1 by 3 change in the concentration of the product Fe2SO4 thrice divided by change in time. So here you have to find the production of Fe2SO4 thrice only. So you have to find the value for this term. So let us rearrange this equation. So we can rearrange this equation for that term. So the change in the concentration of the product Fe2SO4 thrice divided by the change in time is equal to, we are taking this 3 to the other side. So already you are having minus 1 by 6. So minus 3 into 1 by 6 into the rate of the disappearance of the reactant FeSO4. So first the numerator is change in concentration of FeSO4. So here the concentration is given. So the change in concentration of FeSO4 is equal to final concentration minus the initial concentration. So the final concentration is given as 8.8 m minus initial concentration is 10. So the change in concentration is minus 1.2 capital M. And the time, change in time is given as half an hour. So half an hour is 30 minutes. But if you see the unit of rate, time is given in seconds. So 30 minutes is equal to 30 into 60 seconds. So let us keep that. So here we can cancel this. We will get 2. So minus 1 by 2 into the numerator is minus 1.2 divided by the denominator 30 into 60. So minus minus will get cancelled. So we will get 1 by 2 into 1.2 by 30 into 60. So 2 and 1.2 we can cancel as 0.6 and 0.6 and 60 we can cancel. So you will get 0.01. So the leftover is 0.01 by 30. So you will get the answer as 0.000333. So here if you see the answer, it is in 10 power minus 6. So you have to bring the decimal point after 6 digits. 1, 2, 3, 4, 5, 6. So now the answer is 333 into 10 power minus 6. So the answer is 333 into 10 power minus 6 mole liter inverse second inverse. The next question is, a first order reaction has the rate constant K equal to 4.6 into 10 power minus 3 second inverse. The number of correct statements from the following. So the first statement is, reaction completes in 1000 seconds. So a first order reaction never goes to completion. So practically a first order reaction never goes to completion. But theoretically it will get completed at infinite time. So when you substitute the value of time as infinity, then the reaction is completed. So theoretically it gets completed at infinite time. So the first statement is wrong. The second statement is, the reaction has a half-life of 500 seconds. So the half-life formula of a first order reaction is equal to ln 2, that is 0.693 divided by rate constant K. So the rate constant value is already given. So when you substitute that 4.6 into 10 power minus 3, you will get the half-life value as 150.65 seconds. So when you do the calculation, the half-life you will get as 150.65 seconds and it is not 500 seconds. So the statement B is also wrong. The next statement is, the time required for 10% completion is 25 times the time required for 90% completion. So we can find this by using the integrated rate law. So the rate constant is equal to 2.303 divided by time into log of A naught, initial concentration of the reactant, divided by AT, that is the concentration of the reactant after some time. So now you can rearrange this equation by taking the time t to the left hand side. So we will get T is equal to 2.303 by K. So now they are telling 10% completion. So 10% completion means, so the initial concentration of the reactant is A naught. 10% means after 10% completion, 90% of the reactant is still present. 90% of the reactant remains in the reaction. So we can write this as concentration of the reactant at time T is equal to 90% of the reactant, which is equal to 90 by 100 into concentration, that is the initial concentration. So you will get 0.9 A naught. So we can substitute this value 2.303 divided by K log of A naught divided by 0.9 A naught. So A naught will get cancelled and the remaining is T is equal to 2.303 divided by K log of 1 by 0.9 is there, that we can write as 10 by 9. So I will continue in the next page. So for 10% completion, we got the time is equal to 2.303 divided by K log of 10 divided by 9. Now you will see the question again. So it is 25 times the time required for 90% completion. So now you have to find the time required for 90% completion. So we can write that 90% completion refers to the reactant concentration, that is 10% of the reactant remains. So the concentration of the reactant at that time is equal to 10% of the initial concentration, which is equal to 0.1 of A naught. So you can again substitute in the same manner. So the 90% completion is equal to T equal to 2.303 divided by K log of initial concentration divided by 0.1 A naught. So T equal to 2.303 divided by K, this will get cancelled, and log of 1 by 0.1 will come, which is nothing but log of 10. So now let us keep this 10% completion as T1 and 90% completion as T2. So according to the question, T1 should be equal to 25 times the time taken for 90% completion. So 25 into T2. So T1, when you take this T2 to the left hand side, T1 by T2 should be equal to 25. So this has to come. So let us check that. We can divide this. So T1 divided by T2 is equal to 2.303 divided by K log of 10 by 9 whole divided by 2.303 divided by K log of 10. So this term will get cancelled and the numerator will become log of 10 minus log of 9 divided by, so the denominator is log 10. So log 10 value is 1 and log 9 you can write as log of 3 square. So the 2 will come in the front. So you can write as 2 into log of 3 divided by, again the denominator is 1. So log 3 value is given in question. Log 3 is 0.48. So 1 minus 0.48. So the answer is 0.52. T1 by T2 we are getting as 0.52. We are not getting as 25. So the option C is also wrong. The time required for 10% completion is 25 times the time required for 90% completion is wrong. So let us go to the option D. So before that you see option E. The rate and the rate constant have the same unit. So for a first order reaction, the rate constant will have the unit as second inverse and the rate of the reaction will have the unit as mole, liter inverse, second inverse. They do not have the same unit. So option E is also wrong. So let us go to this statement D. The degree of dissociation is equal to 1 minus e power minus kt. So let us see that. So I will write the degree of dissociation here. So the degree of dissociation is represented by alpha. It is nothing but the amount of reactant consumed, X, divided by the initial concentration of the reactant. So here we are referring the initial concentration as A. So the initial concentration of the reactant, that is, we used to write like this, concentration of A naught. So this concentration of A naught, now we are going to represent as A. So it is already given in question that it is a first order reaction. So for a first order reaction, rate constant is equal to 2.303 by T log of the initial concentration divided by the concentration at time T. Now, as already told, we are going to represent the initial concentration as A, and the concentration at time T is, from the initial concentration, some amount of the reactant is consumed. So A minus X. Now we can change this logarithm into natural logarithm. So just take this T to the left hand side. Kt is equal to, take this 2.303. When you divide by 2.303, you will get ln of A by A minus X. Now, I want to remove the natural logarithm on both sides. So, you have to raise to the power of E. E power kt is equal to, when you raise the right hand side to the power of E, ln will get cancelled. And E will also get, E and ln will get cancelled. So, the right hand side will become A by A minus X. Now, take the reciprocal. So, the reciprocal will become e power minus kt is equal to, the right hand side will become A minus X divided by A. So, divide the right hand side, divide each term by the denominator. A by A minus X by A is equal to e power minus kt. So, A by A is 1. 1 minus X by A is equal to e power minus kt. So, minus X by A is equal to e power minus kt minus 1. So, what is X by A? X by A is equal to, you have to change the sign. So, minus 1 will become 1, and plus e power minus kt will become minus e power minus kt. So, what is this X by A? This X by A is nothing but degree of dissociation, alpha. So, we got the alpha value as 1 minus e power minus kt. So, the option D is given as the degree of dissociation is equal to 1 minus e power minus kt, which is correct. So, the number of correct statement is only 1. So, the answer is 1. The reaction between X and Y is first order with respect to X and zero order with respect to Y. So, the question given is X and Y both are reacting to give the products. So, the reaction is first order with respect to X and zero order with respect to Y. So, we can write the rate law. Rate is equal to rate constant into concentration of X power 1 and the concentration of Y power 0. Because in question, it is given first order with respect to X, zero order with respect to Y. So, the rate will become rate equal to K X into concentration of X. So, Y power 0 will become 1. So, this is the rate of this reaction. So, a table is given. Examine the data of table and calculate ratio of numerical values of M and L. So, in this table, the concentration of X is given, in which an unknown term is there, L. And the rate of the reaction is given, in which the unknown term is M. So, we need to find the value of L and M, and they are asking us to find the ratio of M and L. So, ratio of M and L is M divided by L. We need to find that. So, in this table, now the first row is known. All the terms are given. In second row, we are having L. So, let us take 1 and 2. So, taking 1 and 2. So, we already found the rate. Rate is equal to K into concentration of X. So, rate is equal to K into concentration of X. So, in the second row, the rate is 4 into 10 power minus 3, which is equal to K into concentration of X is given as L. K into L. Whole divided by, in the first row, the rate is given as 2 into 10 power minus 3. which is equal to K into concentration of X is given as 0.1. So K will get cancelled. So you can find the value of L. So L is equal to L divided by 0.1 equal to, here 4 by 2 is 2. So the value of L is 0.2. So the value of L we got as 0.2. Now let us take the next row, third row. In third row only we are having M. So now we are going to taking first row and third row, 1 and 3. So you have to divide in same way, because we already found for this reaction rate equal to rate constant into concentration of X. So in third row the rate constant is M into 10 power minus 3. So the left hand side is M into 10 power minus 3 is equal to K into concentration is given as 0.4 divided by, and the first row the rate is 2 into 10 power minus 3. So 2 into 10 power minus 3 is equal to K into the concentration is 0.1. So you can find the value of M. So 10 power minus 3 will get cancelled. M by 2 is equal to K will get cancelled. 0.4 by 0.1 is 4. So M equal to 4 into 2, which is equal to 8. So 2 will go to the right hand side, 4 into 2 is 8. So the value of M is 8. So the ratio of M by L. So ratio of M by L is 8 divided by 0.2, which is equal to 80 divided by 2, which is equal to 40. So the ratio of M by L is 40.